Alright, let's talk about big, tough machines. I've seen my share of them, from massive excavators to garbage trucks that could probably survive the apocalypse. But every now and then you come across a vehicle that's in a league of its own. I'm talking about the Ural 63095 Typhoon-U. Now that's a mouthful of a name. But just look at the thing. It's a six-wheeled, 25-ton behemoth that looks like a monster truck and a bank vault had a baby. This isn't your granddad's old army jeep. This is a modern piece of Russian engineering designed for some of the dirtiest, most dangerous jobs on the planet. It's built to move troops and supplies through places where things go boom, and to get them there in one piece. When you first lay eyes on the Typhoon-U, it's hard not to be impressed by its sheer presence. It's got that no-nonsense, get-out-of-my-way look that tells you it means business. This vehicle is part of a bigger family of Russian machines called the Typhoon program, which was a massive effort to create a new generation of armored vehicles. The goal was simple but incredibly difficult: build something that could protect soldiers from the nasty surprises of modern warfare, like roadside bombs and ambushes. So, you might be asking yourself, why go to all the trouble of building something this big and complicated? Why did Russia feel the need to create the Typhoon-U? Well, the answer, like a lot of tough jobs, is rooted in some hard experiences. Think back to the conflicts in places like Chechnya and Afghanistan. Russian forces, like many others around the world, were using older trucks that offered very little protection. They were basically just standard military trucks painted green. That meant soldiers were incredibly vulnerable to ambushes, landmines, and especially the improvised explosive devices, or IEDs, that became the terrifying signature of modern asymmetric warfare. These devastating roadside bombs changed everything. The old way of thinking just wasn't cutting it anymore. The losses were piling up, and military planners realized they had a massive problem. You can have the best trained soldiers in the world, but if you can't get them to the fight safely, you're in trouble. The need was crystal clear. They had to develop a new class of vehicle. They needed something that could withstand the blast from an IED and keep the soldiers inside alive. This led to the birth of the Typhoon program. The goal wasn't just to add a few steel plates to an existing truck. It was to design a vehicle from the ground up with crew survival as the absolute #1 priority. This was a fundamental change in philosophy. What makes the Typhoon-U so unique in this context is its clean sheet design. It wasn't an upgrade, it was a revolution. The engineers started with a blank page and asked, how do we build the safest truck possible? This led to features we'll talk more about later, like a V-shaped hull to deflect blasts and special energy-absorbing seats. It's a concept known as MRAP, or Mine-Resistant Ambush Protected Vehicle. While the United States and other Western countries were developing their own MRAPs for Iraq and Afghanistan, Russia was working on its own domestic solution, tailored to its specific needs, its climate, and its vast, often unforgiving terrain. The Typhoon-U was built to operate everywhere, from the frozen tundra of Siberia to the dusty plains of the south. Let's get our hands dirty and look at what makes this beast work. When we talk about a vehicle like the Typhoon-U, it all starts with protection. That's its whole reason for being. The armor on this thing is a combination of composite materials and space steel plates. Think of it like a layer cake of toughness. It's designed to stop not just small arms fire but also heavy machine gun rounds and shrapnel from artillery shells. But the real genius is underneath. The truck has a V-shaped hull, which is a brilliant piece of engineering. When a bomb or a mine detonates beneath the vehicle, that V-shape channels the explosive force out and away from the cabin, instead of straight up into it. It's a simple concept with life-saving results. Then you have the stuff you can't see. The cabin where the crew and soldiers sit is a fully armored, monocoque capsule. That means it's a single solid shell, completely separate from the engine and the frame of the truck. This design helps maintain the integrity of the crew compartment even if the rest of the truck is heavily damaged. Inside that capsule you'll find special seats that are attached to the ceiling or the walls, not the floor. This is critical. It means that if there's a blast from below, the shock wave doesn't travel directly up through the floor and into the soldier's spine. Of course, a rolling fortress isn't much good if it can't move or fight back. Under the hood, the Typhoon-U is powered by a hefty YAMZ diesel engine, putting out around 450 horsepower. That's enough grunt to move its 25-ton bulk at speeds up to 65 miles per hour on the road. It's got a 6-wheel drive configuration and a hydropneumatic suspension system, which means it can handle some seriously rough terrain. For firepower, it's typically armed with a remotely operated weapons station on the roof. This lets a gunner, safe inside the armored cabin, control a heavy machine gun or an automatic grenade launcher using a joystick and a video screen. It's like playing a video game, but with very real consequences. No machine exists in a vacuum, especially not in the world of military hardware. The Typhoon-U has a lot of competition out there. You have to look at it next to its international counterparts to really understand where it fits in. The most obvious comparison is with the American family of MRAPs like the Oshkosh M-ATV or the Navistar Max Pro. These vehicles were the pioneers of the modern mine-resistant design, built in massive numbers for the wars in Iraq and Afghanistan. They proved the concept worked and saved countless lives. The M-ATV, for instance, is a bit smaller and lighter than the Typhoon-U, designed to be more nimble in tight urban environments, which was a key requirement for its development. The Typhoon-U, on the other hand, seems to be built with a different philosophy in mind. It's bigger, heavier, and can carry more soldiers, up to 16 compared to the M-ATV's 4 or 5. This suggests the Russians are thinking about moving larger squads of infantry at once, perhaps across the vast open spaces they often have to operate in. While the American M-ATV is like a heavily armored dune buggy, the Typhoon-U is more like an armored bus. It's less about zipping through narrow alleys and more about rumbling across the countryside with a full load of troops ready to dismount and fight. Looking at other global players, you see different approaches to the same problem. Germany has the Dingo 2, a highly respected vehicle known for its excellent build quality and crew protection. South Africa, a true pioneer in this field, developed the Caspier and later the RG-31, which heavily influenced American MRAP designs. Each country builds a vehicle that reflects its own engineering culture and perceived military needs. The Typhoon-U stands out for its sheer robustness and its emphasis on being a multi-purpose platform. Its large, modular design means it can be adapted for a wide variety of roles, a feature that is becoming increasingly important for modern militaries looking for cost-effective, versatile solutions. So where does that leave the Typhoon-U? It's a heavyweight contender in a field of tough competitors. It may not be as nimble as some or as widely combat-proven as the American MRAPs, but it brings its own strengths to the table. Its combination of heavy protection, large troop capacity, and rugged go-anywhere mobility makes it a formidable machine. A machine can look great on paper and perform perfectly on the test track, but the real measure of its worth comes from the dirty, unpredictable reality of the real world. For a military vehicle, that means the battlefield. The Typhoon-U, since its introduction, has been put to work. It's been a prominent feature in military parades in Moscow, a clear signal of its importance to the Russian military. But beyond the parade ground, it has been deployed with Russian forces in various operational roles. Most notably, these vehicles have seen service with Russian military police units in Syria, a complex and challenging environment for any piece of equipment. In a place like Syria, the threats are constant and varied. You've got the risk of IEDs, ambushes from insurgents, and the simple but brutal wear and tear of operating in a harsh desert environment. The Typhoon-U was sent there to do exactly what it was designed for: protect troops as they move through dangerous territory. Reports and images from the region have shown these trucks escorting convoys, securing checkpoints, and providing a safe, mobile base for soldiers. Their imposing size alone can act as a deterrent, sending a clear message of strength. The experience gained in these real-world deployments is invaluable for the engineers back home, providing feedback on what works and what needs to be improved. The vehicle has also been seen in the recent conflict in Ukraine, although its role and performance there are harder to analyze with certainty due to the fog of war. In any conflict, even the most advanced vehicles are vulnerable. We've seen images of damaged and destroyed Typhoons, which is a stark reminder that there's no such thing as an invincible machine. However, the key question for military analysts isn't whether a vehicle can be destroyed, but how well it protects its crew when it is attacked. A successful design is one where the truck might be disabled, but the soldiers inside survive to fight another day. That's the entire point of the MRAP concept. The operational use of the Typhoon-U is a critical part of its story. It's the final exam after years of design and testing. Every mission it undertakes provides more data. The introduction of vehicles like the Typhoon-U isn't just about getting a new truck. It's about changing how you think about fighting a war on the ground. For decades, military logistics was seen as a soft target. The supply trucks, troop transports, and ambulances moving behind the front lines were vulnerable. But when your basic transport truck is a 25-ton armored beast that can shrug off machine gun fire and mine blasts, the game starts to change. Suddenly, those logistical chains become much harder to break. This allows an army to operate with more confidence, pushing supplies and reinforcements forward with a much higher degree of security. This new level of protection also changes battlefield tactics. Commanders can be more daring in how they move troops around. With vehicles like the Typhoon-U, you can transport infantry through areas that would have been considered too risky before. This allows for faster troop movements and surprise maneuvers that can catch an opponent off guard. Furthermore, the modular nature of the Typhoon-U transforms them from simple transports into versatile combat platforms. By swapping out the module on the back, the same basic truck can become a command center with advanced communications gear, a mobile mortar carrier to provide fire support, or a sophisticated reconnaissance vehicle packed with sensors. So, what does the future hold for big beefy trucks like the Typhoon-U? If you listen to the experts and military analysts, one thing is clear: these types of protected vehicles are here to stay. The need to protect soldiers from mines and ambushes isn't going away anytime soon. But the technology is constantly evolving. We're likely to see armor get smarter and lighter. Instead of just relying on thick slabs of steel, future vehicles will use advanced composite materials and even active protection systems, or APS. These are like a shotgun shield for a truck, using radar to detect incoming rockets or missiles and then firing a projectile to destroy them before they hit. Another big area of evolution is in the brains of the vehicle. We're talking about more advanced sensors, better communication systems, and increased automation. Imagine a Typhoon-U of the future that can use its sensors to map out the terrain ahead, identify potential threats, and share that information instantly with every other vehicle in the convoy. In the end, the evolution of armored vehicles like the Typhoon-U will be a story of adaptation. They will become more connected, more intelligent, and more protected. They will integrate more technology to reduce the burden on the soldiers inside and to give them a better understanding of the world outside their armored shell. The core job will remain the same, doing the dirty, dangerous work of moving people and things through hostile territory. But the tools to do that job will get sharper, smarter, and tougher. The Typhoon-U is a major step in that evolution, but it's just one chapter in a long book that is still being written on the battlefields of today and tomorrow.